Okay, so this slope field page is on Classroom, so y'all at home can print this. We're looking at, and some of them aren't implicit derivatives, like this one's not, it's just in terms of x. How we draw a slope field is we consider this as our xy chart, and at each little dot, we're going to draw a tiny little slope. Slope field represents the slope at every dot, or every xy coordinate. So you can do it, something as simple as x, you can do by, thinking through it and not necessarily doing an xy chart. Or you could do an x sort of slope chart, meaning if you plug in an x value, you're going to get the slope out. So let's do this. And in this case, I only had to put x in there because x is the only thing that's going to change my slope. So I did that really without thinking about it. But when I do this one, my chart's going to have a y in it, right? Because I'm going to change y. So let's look at this one and graph these together. If I'm looking at x, I have 3 different x's here. I have -1, 0, and 1. Does it matter what my y is? No. So at -1, if I plug in -1, I get out dy dx equals -1, which is slope. So what does -1 slope look like? At -1, it looks like this. So a little tiny 45-degree angle line. That's all there is. If x is -1, but y is -1, it's still this, and it's still this, and it's still this. Those are all supposed to look the same. Y was not a factor in this equation. Do you see how that is? How about the slope at 0? It's 0. So 0 slope is horizontal, and it didn't matter what my y is the same. And then how about at 1? It's 1. So we draw a positive slope. Now we have a slope field. What does this slope field look like? Well, it looks like if we connected the dots, these would be parabolas. They kind of really go in the middle, sort of like the in-between at the other points. But that makes sense, right? Because if this is a first degree, this would be a second degree. So I don't know what my C value is. I don't know which of these lines would be the one, but I just want to be able to see a parabola in there. So this slope field sets you up to be able to see what the original equation was. So y is also going to be similar. When you look at y, you're going to not consider the x. It's going to be based on the y's. What y values do we have that we need to put in our little chart? Yeah, so there's 4 this time. 2, 1, 0, -1. And I only need to consider y's. They're the same, so whatever y was, my slope is at 2, 1, 0, -1. That was easy. Then we just have to think about how to graph 2. So at y equals 2, 1 would be here. This is like a little bit steeper. How do they grade you on an FRQ? Well, they're going to grade you on the 1s and the -1s. You might have a 2. You're not going to have anything bigger than 2. But 1 should look like 45 degrees and positive. 2's going to look a little bit steeper. What they're going to be able to tell is when you change to negative. So 0 slope at 0, and then -1. What does this antiderivative look like? So at the x-axis, if you were going to infinity, it would be like that, and then it would start to go up, right? Can you see it? So what does that look like? What function is that? sort of like this. Can you guess what that is? It's not an exponential. What's the other choice? Yeah, so a natural log. So you're only going to have natural logs. And is this the natural log? This whole section of stuff, all of the concepts they intermingle. So I do want to go ahead and solve this so you can see that it's the natural log. And that will also be introducing us again to what it looks like to be separating our variables and doing antiderivatives of differential equations. This is a differential equation. Why? Because it has a derivative in it. So it has a derivative, it's differential, and it's an equation. And the purpose of those, in order to solve it, we're trying to find the original equation, so the regular y. So I'm going to do that here. So dy dx equals y. That's given. I didn't do anything. I just rewrote it. In order for me to take an antiderivative, I need all the y's together and all the x's together. So I'm going to multiply this side by dx, and that's gone. Now I have dy. I'm writing these out. You don't need to write quite this much when you do it. Some of this you can do in your head. How do I get y on the other side? Divide by y. So if I say 1 over y, and so now my y's are gone. So now I have this, 1 over y dy equals dx. And if I have derivatives, how do I undo derivatives? You take the antiderivative, you integrate both sides, you draw the little integral sign, which of all the things that we do and I don't leave enough room, that one I have room for, which brings me small joy. What is the antiderivative of 1 over y? Natural log of y equals, this is 1. So how do I take an antiderivative of 1? No, antiderivative of 1, it's x. And then we put a plus c. We're just going to put a plus c on one side. And I was thinking natural log, but I said it wrong earlier. This really is an exponential equation because why? Because why? Logs are the inverse of exponents, so how do you get this to be y equals? Because that's our goal. Yeah, so I don't know how actually the right term is, but I say raise both sides to e, or make this the exponent for e. So I'm going to e this side and e that side. And it's the whole side. And we end up with this cancels, and we get y equals e to the x plus c. I'm going to leave it there from now. We're going to solve that more later, but this looks like an exponential now. Depends on what c is. These look like exponentials that have a negative. It has been flipped over, and I don't know what c is, so they could totally do this as well. They could also go down. I don't know what my c is, so I can't solve for that. So these go together. And if you're trying to find a particular solution, if they said the solution that goes through 1, 1, you'd say, well, it's closest to this one, and it looks like this. That's kind of how you would solve it as far as the picture goes. But basically, they just want to know, can you draw tiny slopes that represent an implicit derivative? Okay, so on this, because the slope fields are already here and it's convenient, work on 3 and 4 and think about what it means to be 5 and 6. And then you'll have to match on the last page. They're already here for you. So this is kind of like setting you up for the multiple choice questions that you saw in your exam. So you have a couple problems that are in the book, but you can finish this worksheet in class, ask me questions, and if we have, we'll just go over it tomorrow. That gives everybody a chance at home to catch up and do this, and we can look at it tomorrow. So come to class, because that's the only way I can go over the multiple choice on the actual practice exam with you, because I can't put that on the recording. All right, we'll see you later.